Hi guys, thank you and welcome to our channel of Sciences and Mathematics. I kindly request for some of us who have not subscribed, kindly go to YouTube and search Sciences and Mathematics, or at the best Heritage 6110, so that you can be able to subscribe and get our updates as we upload them, and interact with us on the comment section so that we can improve our skills, of course, in Sciences and Mathematics. So for today, we're going to look at a different class of organic compounds, of course, which falls under aromatic chemistry, and that is disubstituted benzenes. Now, this class of organic compounds are very important because we are going to see that substitution at different points on the benzene molecules are going to dictate its chemical and physical properties, in a sense that the substituents that already exist, or the ones that have substituted on the molecules, are going to dictate, of course, how other molecules are going to join with the benzene ring and other aromatic compounds. So for that case, thank you and welcome. So as I've said, today's topic is going to be centered around a different category of substituted benzene, and that's going to be disubstituted benzenes. And as I've said, we talked about the relative positions of benzene molecules, which we denoted, of course, as auto, meta, and para, when we were talking about different substitution points. So maybe we can just have a small demonstration still for a recap. So in this case, I'm going to use the heterochemistry structure for benzene. So in this case, the numbering, of course, can start even at this point: 3, 4, 5, 6. But we just use the normal structure that we used to, so for the sake of numbering, so that we not. So we said with respect to x, the substitution at these different points is going to be given specific names. So a substitution at this point with respect to x is going to be given the term auto, at this point meta, and para. So this one implies that this one is similar to this point, of course, and that is going to be meta and para respectively. So in this case, whenever we mention the term meta or para, we are going to use this initials for para, meta, and auto, implying that this molecule or substituent has been substituted at a point that is auto, meta, and para with respect to the point x. So in this case, for disubstituted benzenes, they are differentiated using the word auto, meta, and para, as I've said, and the relative positions can be denoted using the terms, of course, the different points. Either it's point number 1, 2, 3, 4, 5, 6, of course, as they appear in the benzene molecule. 4, 5, 6. Of course, if that is with respect to the molecule that has been attached at that point. So whenever we are giving reference, because this is the numbering for this, we will just begin at this point. So we're going to give the position of that molecule with respect to x. So we're going to give a different range of disubstituted benzene molecules and try to see which are some of the common names or the names that we've given before that refers to those specific molecules. So in this case, if I draw this molecule, and then I have a substitution at this point for the chloro, and then there's another molecule that is attached to this point. I said for this, the monosubstituted benzene for a methyl group at this point, we call this molecule a toluene. So for this toluene molecule, there's a substitution at this auto position, so we shall give it the name O for auto, chloro. Oh no. So chlorotoluene. So this is auto with respect to this methyl group, of course, that is at this point. Of course, for the line diagrams, we can just represent a methyl group as that. So this is auto chlorotoluene for that molecule. So that's the name that we're going to use for that disubstituted benzene. And then suppose we have a cyano group and then a chloro at that point. Of course, we gave this name as cyano benzene, but there's a chloro at that point. So it's at point which is of course, just relocate it to this point, maybe to give it a difference from the first one. there's a chloro at this meta position for that particular molecule. So we shall have a name given as meta chloro. So this is a cyano group. So there's a meta cyano chloro benzene. So meta, it's a meta, initial meta for this chloro, cyanochlorobenzene. This is cyanochlorobenzene, but there's a chloro at the meta position, so that is how it is going to be named. And then we have another, of course, substitution at this particular point. It's an iodo, and another one at these two specific points. So this one will be a para. Those points that are in line with this one is known as a para diiodo. Check whether this diiodo benzene. This is a para diiodo benzene. And then suppose we have similar groups, of course, just different from the iodo, like the nitro group that is having a substitution at this point, and this one. And that compound we can name it as ortho dinitro benzene. So double substitution and a di-substitution at those specific points, we are going to have that molecule. And then let's look at a different, of course, substitution and try to see how we can be able to name it. Suppose we have a OH group at that point, and then there's an isopropyl. That's at that point, of course. So that one, we shall have a isopropyl. So that's an isopropyl. This is an alcohol, of course, we shall have isopropyl phenol. We say that a substitution for the OH group.